Hi everyone. In these next few slides, we're going to start reviewing for the midterm exam. So to get started here, I just wanted to give you a few tips about how to best prepare for the midterm. First of all, we hope you'll ask us a lot of questions. If you're not sure about something, please get in touch with us as you're going back through your materials. We hope you'll post questions and email questions to us. We're always happy to help you. We want you to review assigned chapters from the textbook and the accompanying lecture notes. So be sure to go back through the materials from the first several weeks of the course up through the midterm and look carefully at all of those materials. Go back and look at your homework assignments. So especially we want you to look at problems that you missed. Do you understand why you missed those problems? Do you understand what the correct answers are and why? If not, please let us know. Sometimes we do select problems from the homework assignments to include on exams, so we want you to be prepared for that. We want you to look back through the lab activities that you completed. All of the answer keys are posted up on Canvas. So once we finish, or once we once we close an assignment, we try to post the answer key as soon as possible, and it's up to you to look at those keys. Look especially at problems that we did not grade. So your lab activity, when we give you a grade, we don't grade every single question. So there might be some questions that you didn't get correct. And again, we want you to understand the correct answers. We also sometimes pull questions from lab activities and include them on exams. So we want you to be prepared for that as well. And we also want you to work through extra practice problems that we've posted and ask questions about those if you have any or if you run into problems. So we hope that you'll have ample time to review, ample time to ask questions. We want everyone to feel really confident going into this exam. So what I've tried to do with this particular set of slides is just to put a few questions together from different things that we've studied over the last several weeks and just to test you. So one thing you might do is maybe stop the slides now or stop this lecture now and look at all the slides and try to answer the questions yourself, and then come back and check your answers against what I'm going to share here. So one thing we talked about was a particular measure of variability called the standard deviation. So is this a true or false statement? If all the values in a data set are negative, the standard deviation will also be negative. I'm hoping you're saying false to this. And I'm hoping the reason for that is that hopefully you all know that the standard deviation can never be negative. It's always positive. And if you look back through our discussion of that when we first covered it in Chapter 12, you might think about the question we worked through where I had a very small data set and I asked you to think about finding the standard deviation by hand. When we did that, you might have noticed that along the way we had to square some things. We had to square some values, and then we took a square root. And that process of squaring is what ensures that the standard deviation is never going to be negative. It can be 0, but it can never be negative. True or false, the only way a standard deviation can be 0 is if all data values in a data set are equal to 0. So again, I'm hoping that you're thinking that's a false statement. So a standard deviation of 0 means we have no variability. It could be that all the values are 0, or it could be they're all 100, or they're all 50, or they're all 25. Anytime all the values in a data set are exactly the same, then we would have a standard deviation of 0. So let's talk about some statistics in the news. Here was a headline that caught my attention a while ago. Broccoli eaters get more out of life. This actually caught my attention because my husband doesn't really eat vegetables except for broccoli. He really loves broccoli, so I thought maybe I could share this with him. Let me tell you a little bit about this particular study. So in this study, there were 405 participants. They were university students, and basically they kept a diary for several days of the numbers of servings of fruits and vegetables that they were eating. So that was kind of the gist of it. So they kept track of servings of fruits and vegetables, various potato dishes as well, desserts, and then they filled out questionnaires each day about their well-being, how they were feeling, curiosity, creativity, etc. So you can read a little bit here. And if you want to, you can go to the original media link and find out a little bit more about the study. So the results of the study were basically that individuals who ate more fruits and vegetables reported higher levels of curiosity, creativity, and positive emotions, and several other really positive things. They also tended to score higher on all of these scales on the days when they actually ate more fruits and vegetables. So in the end, the main idea here is that eating fruits and vegetables is good for you. It leads to lots of positive, really great things. So let's dissect this a little bit. So I'm only telling you a little bit about the study, but let's talk about some things. We might give you something like this on an exam. We might give you a snippet. We might tell you about a study, and we might ask you some questions, give you some things to think about. So one thing we might ask you about is, who do you think the population is for this particular study? And this could be answered in different ways. I think we could make a case that the population could be all university students. That could be a possible population. Maybe all adults. So the population is the bigger group we're trying to say something about, and it's not really clear from that particular snippet, but again, I think we could make a strong argument. It could be all students, it could be all adults. Who is the sample? So the sample is the students that we included in the survey. So the 405 students. What are the individuals? So we want you to remember that in a study, the individuals are the cases. They're the ones who get the treatments, or they're the ones who we're gathering information about. So here, the individuals are people. Suppose it was reported that within the sample, the average number of servings of vegetables eaten per day is 1.5. Is this number a parameter or a statistic? So we're talking about the sample. So hopefully you remember that a number that describes a sample would be a statistic. If we give you information that describes the population, that would be a parameter. Is this an example of an experiment or an observational study? So hopefully you're thinking it's an observational study. The reason being that we're not imposing a treatment of any kind. We're just observing what people naturally do. We're having them record what they would normally do. We're not trying to intervene or manipulate the situation in any way as we would with an experiment. So maybe right here I'll just write no manipulation. There's no control of possible lurking variables. So a few more things to think about related to this. This is actually a segue here. So we're looking at another study about fruits and vegetables. So in 2007, the National Cancer Institute's Food and Attitudes Behavior Survey was mailed to a random selection of 5,803 adults, and a total of 3,418 actually responded to the survey. So our sample is the 3,418 who responded to our survey. The fact that some individuals did not respond to this survey would be what kind of error? A sampling error or a non-sampling error? So hopefully you're thinking about non-sampling errors. So we've reached out to a lot of people. We chose a sample, a random selection of a lot of individuals. The people then could choose whether they're going to respond or not respond. So it's a non-sampling error, and we call it a non-response error. Let's say that it's later found that Asian Americans were underrepresented in the sample. This would be an example of what kind of error? So this would be a sampling error, where there's something wrong with our sampling and we're not including everyone we should be including. And you might remember reading about this kind of error. It's called undercoverage. So sorry about my writing. That should say undercoverage. A few more things to think about here, again related to fruits and vegetables. The Food Attitudes and Behaviors Survey was developed with the goal of evaluating a variety of factors that may be related to fruit and vegetable intake among adults. Let's say that in a new sample, where the sample size is 3,021, it's found that only 6% of the sample was aware of the recommendations for daily fruit and vegetable consumption. So let's say we give you this information and we ask you to estimate the margin of error and to think about what a confidence statement would look like. So I'm hoping that you're remembering to estimate the margin of error, we would want to use that quick estimate for the margin of error. So the quick estimate is 1 divided by the square root of n, and then we'd multiply all that by 100% to express our answer as a percentage. If you do that here, you're going to end up getting approximately 2%. So 1 divided by the square root of 3,021 ends up being about 0.02, and you multiply that by 100% and you get 2%. What would a confidence statement look like? So I'm going to write it up here. We are 95% confident, so we'll assume 95% confidence, if not otherwise told the confidence level. We are 95% confident that between 4% and 8% of adults are aware of the recommendations. So again, I'm sorry about my terrible writing here. So we are 95% confident that between 4% and 8% of all adults, of the population of adults. So make sure that you're making your confidence statement about what you think is going on in the population. We are 95% confident that between 4% and 8% of all adults are aware of the recommendations for daily fruit and vegetable consumption. So I'm going to stop this here, and then we will continue on with a second video.